Hello and welcome. We are going to look at two types of circuits for this video. They are called series circuits and parallel circuits, and we start off by looking at series circuits. Now, what a series circuit is when we have a circuit set up so that the current will flow through a single pathway. There's only one pathway that the current can follow, and therefore we call it a series circuit. Now, in my series circuit here, I've got three resistors, so resistor 1, 2 and 3, and the first rule to remember about a series circuit is that the total resistance is the sum of all the individual resistors or components. Now, I say resistors or components. Here I've got resistors, doesn't have to be resistors. Here I've got a diagram with some lamps in it. So these components, these lamps, also offer resistance as well. And to work out the total resistance in this circuit, we just add them up. So if this had a value of 10 ohms, 10 ohms and 10 ohms, we could then add up the values and we would have a total resistance of 30 ohms. Just a simple case of adding them up. Similarly, if we had 10, 20, 30 different resistances on these, it's just a case of again adding them up. There we would have 60 ohms. Okay, so that's the first rule that you should remember. The second rule, or no particular order, but another rule, is the total potential difference of the cells is the sum of the individual cells. So if I was to measure the potential difference across the two cells, that would give me a value, but that value would be the sum of the individual cells. So if this is a 3 volt cell and this is a 3 volt cell, the total potential difference would be 6 volts. The only way that might not work is if this was connected incorrectly and one of the cells was the opposite way around. That would cancel out and there would be no potential difference across the two cells. They must all be facing the same way. Okay, so that's the rule about the cells in the circuit. The third thing that I want you to remember is that the potential difference of the supply is shared between the components. So here's my supply. In this case it's cells, but it could very easily be a power pack or something like that. So if I've got the three resistors set up as shown, it says here the potential difference of the supply is shared between the components. So that means if I measured the potential difference here, it would be a share of this 6 volts. In actual fact, in this case, because these are identical resistors, this would be 2 volts, 2 volts and 2 volts, because it's that 6 volts that's shared between the components. Okay, so that's a very important thing to remember. And the last thing is that the current is the same through each component. So in fact the current is the same in any part of this circuit. So if I measured a current of 0.3 amps over here, wherever I measured that current, I could take it anywhere in the circuit, either between these resistors, anywhere along the circuit. That current would always be 0.3 amps. The current stays the same in all parts of the series circuit. Okay, so these are 4 important things that you must remember about series circuit. The next thing I want to go through is the idea of the parallel circuit. So in parallel circuits, we have a circuit that's set up that has branches. So in other words, the current can flow through different branches in the circuit. And there are a couple of rules that I'd like you to be able to, or I'd like you to know, remember, and be able to apply if you need to. The first one here says the potential difference across each component is the same. So here I've got 2 components. These are again chosen resistors. So here's a resistor and here's a resistor, and the potential difference across each of those is the same. So if the potential difference here is 3 volts, over here it's also going to be 3 volts. Okay, so that's applying that first rule. The second rule sounds a little bit more involved and a little bit more complicated, but it's actually not. It says the current is different in different branches of the circuit, and here it says the total current through the whole circuit is the sum of the current through the separate components. Now, what does that mean? Well, if I have a current here of 0.6 amps, when we reach this branch here, this current can actually split into 2 directions, and we say that we have a current of 0.3 amps here and 0.3 amps here. As long as these 2 resistors are the same, they have the same value, the current will split equally between the 2. And again, when it gets around to the other side, when it flows to the other side, we will have a current of 0.6 amps again, because the 2 join together, two values are joined to make the value of the current at this point here. If the resistors have different values, you might get more current going through one and the other. So if this was very large resistance and this was very low, you would get more current going through the low resistance than the large resistance, and that is because the higher the resistance, the lower the current, and that's quite an important thing to remember. So I've highlighted that in red. Okay, so if I had a larger resistance here, the current would be lower and it would be a higher current here because we've got a low resistance. But all things being equal, if the resistances are the same, the current would split evenly between those two branches. Okay, so let's have a quick summary look at this. We've got these rules here, gone through those already. If I gave you some numbers here, so I've got 4 amps or 0.4 amps through this branch of the circuit, the two resistors are exactly the same value, so that's 10 ohms and 10 ohms. What would be the current in different parts of the circuit? Well, we could say if that's 0.4 amps, that branch there will also be 0.4 amps. That means the current in this ammeter would read 0.8 amps, and on the other side there, that would also read 0.8 amps. So we're applying this rule here to work out the current in the different parts of the circuit. Okay, if the potential difference across this resistor is 12 volts, what's the potential difference across this one? Well, it's shared. No, it's not shared, it's the same across each component, so this one will be 12 volts as well. Okay, so similarly for a series circuit, here's some different values. Here are the rules, we've gone through those already, but if I've got 12 volts in the supply here, 12 volt supply by this cell, what would be the potential difference across each of these lamps? Well, we know that the total potential difference of the supply is shared, so this would have 4 volts, 4 volts, 4 volts. If these lamps are identical lamps, that would be shared, the potential difference would be shared between them. The other thing is that we've got a current here of 0.4 amps. What's the current over the other side? Well, we know the current is the same in the circuit, so it would be also 0.4 amps. In actual fact, wherever we measured it in this circuit, in the series part of the circuit, it would be 0.4 amps. Okay, so that's applying it in a slightly different way for these two circuits with some different values in there. This is something that you can get quite confused about, so you might want to go over it once or twice just so that those rules are actually in your brain and you remember those for when you need them. But other than that, that's me done for now. Thanks for watching, and I'll see you again soon.